during the talk, the presentation skills, everything will be assessed by the jury, and the award will be given to the best presenters. Now, the most important, why to become an IGU member, for student member. Become a member of Indian Geophysics offers numerous professional, academic and research benefits for individual interested in geophysics, earth sciences and allied fields. The advantage is what we is we get receive the IGU journals regularly, gain access to seminars, conferences and workshops, have an opportunity to interact with the leading scientists, academicians, researchers and industry experts, get a chance to present your research papers, case studies and findings. To strengthen your professional profile. What you have to do is, for research the membership is 2,500. The period is 5 years from the date of membership till complete of the PhD. For IT student membership is 1,500 rupees. 2-3 years for the date of membership till completion of the masters. What provide, they have to submit an abstract and send a request for financial support. For that, what we provide is participation in the annual convention, registration fee waiver, sleeper train charges, and accommodation. The main thing is you have to submit an abstract. You have to be the member of the IGU student member. This member you can be put in the online also. www.iguonline.in. We invite you all to join IGU as a member to help to shape your future. Thank you.
Thank you very much, Dr. Prasad. It is always customary that this particular talk is from the IGU, but in the name of Dr. Harinarayan Lifetime Achievement. It would be nice to hear about, especially for the younger generation here, who this Professor Harinarayan is and what is accomplished. Try to have a very brief video for about 2.5 to 3 minutes. Can we request the video, please? Good morning to the dignitaries on the dais and off the dais. Professor C.V. Naidu, the head of the Department of Geophysics. Professor Sri Krishna, who is the recipient of today's award, Dr. Harnarayan Lifetime Achievement Award, Dr. A.S.S. Prasad, and my respected teachers here, Professor Radhakrishnan Garu, and Dr. Prasad and others, and the distinguished alumni and the student members. I think it's an occasion where though we are calling it as an IGU event, I always say it's an integral part of the Department of Geophysics. It has got a lot of linkages. When IGU was started almost about 63, 62 years back, the prime members of IGU, 90% of them are from Andhra University and partially from BHU also, because there were the two institutions which started geophysics long back. And more so, IGU, as all of you know, it has its origin in NGRI. And while NGRI was started, I think it's the pillars of the institute were mostly from Andhra University. The senior teachers from this place or senior researchers of this place have gone to NGRI and started research in those days. So that way, IGU is really a real part of this institution and the geophysical community. Now coming to this particular event, this Dr. Harnarayan Lifetime Achievement Award was initiated only about 4 years back or 5 years.
10 years.
One decade is over. Yeah. So now, so this particular award, when we are extremely happy to have this function here for two reasons. One, I said our long association with IGU. The second most important factor is this year's recipient or the awardee is Professor Sri Krishna, who is an alumni of this particular department. And more so, it's coinciding with our Platinum Jubilee celebrations. I think now, without losing much of a time, I would like to introduce Dr. Sri Krishna to this august audience, more so for the younger generation who are sitting here, who are really the future of the nation. Dr. Kolluri Sri Krishna, a distinguished professor and Dean of School of Sciences in Geetham University, Visakhapatnam, is a proud alumni of Andhra University, Department of Geophysics, having obtained his highest academic degree, the Doctor of Philosophy in Geophysics, in 1996, under the guidance of Professor I.V. Radhakrishnan Garu, who is a doyen of this particular subject, who made the subject to be known all over the world, and the department's credit has gone up because of his contribution. Sri Krishna, after a very brief stint as a seismologist in Geophysical Services Inc., a subsidiary unit of Texas Instrumentation dealing with petroleum industry, he served NIO as a scientist for over 33 years, rising to the level of a senior most chief scientist. With these academic and research accomplishments, he joined the University of Hyderabad as the professor and head of Earth, Ocean, and Atmospheric Sciences. His research focus was on the evolutionary processes and linkages of Earth and ocean sciences and the associated plate tectonics and lithospheric dynamics in the arena of marine geophysics. His work on the eastern continental margins of India
testifying the sediment depositional pattern in the Bay of Bengal vis-a-vis the rapid uplift of Himalayas and the plate breakup processes in the Indian Ocean gained India an international credibility by putting forth its claim on an additional seabed territory under the legal continental shelf program. This is a real big contribution which India could achieve indirectly from the work and the leadership of this gentleman, Dr. Sri Krishna here. He has been a Shantiswarup Bhatnagar Award Web Prize winner in 2001, and he is one of the very few earth scientists in this country who are honored by all the three main Indian national science academies with their fellowship, be it INSA, Allahabad, and Bangalore as academies. No wonder to mention that he has also enjoyed the JCBS fellowship for some time in the middle. Apart from many of these awards, many honors like INSA Royal Society UK Fellowship, then International Fellowship of Royal Society of London, etc., were obviously embraced him for quite some time during his professional career. He served in various editorial capacities for journals like JGR, INSA Academic Publications, Current Science, and many more. As I said once again, maybe it's important to repeat that his leadership role as the chairman of the Commission for Limits of Continental Shelf has led to the country's progress to claim additional seabed territory on both the continental margins of India. He has the unique distinction of being a scientist par excellence with significant contributions in the field of ocean sciences, bringing India to the forefront on the world map. Anything said about him reflects only a tiny part of his accomplishments. I think it would be very difficult for me to keep on narrating of geosciences. But more importantly, the younger generation, here you are. You have an elder brother here who made wonderful things. And we also have Professor Radhakrishna who is also here, guide. And then I think these are the pillars of geophysics from Andhra University. I would put it that way. So I now with these few words, I humbly present Dr. Sri Krishna, the latest and most illustrious recipient of the Dr. Harinarayan Lifetime Achievement Award of IGU to this august audience. Thank you very much. May I now request Professor Radhakrishna Garu and Dr. Prasad to come on to the dais to facilitate the award here on behalf of IGU, please. Master. Master. For a student to get the award from, the felicitation from a teacher, nothing like that. Thank you, sir. Now, I think before we really, yeah. Oh no, yeah, it is Nightgara. Okay. Nightgara, would you like to say a few more words? Would you like to say a few more words? Huh? Okay, thank you. So now may I request Dr. Sri Krishna to proceed with his talk, please. Oh yeah, okay. I'm sorry, I have one more small thing. On behalf of IGU, may I now request Dr. Prasad, and I will also join him, to felicitate Professor C.V. Naidu, who is our head of the department, who facilitated this. But not only that, but I think the last 3 days of activities, he is the boss of everything, and then he is the architect, he is the whole worker for it, and then supported by all his colleagues in the department and students in the department. It was really a very memorable occasion for every one of us, not only for the past students, but for the present.
and including the teachers who have served this university. It's a very proud occasion. Thank you, Nadigar. And this is small token of appreciation from IG.
He deserves a standing ovation, really.
In seminar, the platinum jubilee celebration in hill station. And teachers అందరూ ఒకసారి బయట సార్
Please stay, sir.
Part of AG is a part of this department.
Please stay, sir. Please stay, sir.
రాజేంద్ర కృష్ణ గారికి రండి సార్ స్పెషల్ గా చేద్దామని ఐడియా
Please, sir. Okay, sir.
Start with presentation. First slide.
Presentation, I now request Dr. Krishna, please.
కుర్చీలు తీసేస్తాం కుర్చీలు తీసేస్తాం అది కాదు బాబు తీసేయండి బాబు బాబు కుర్చీలు కింద పెట్టండి ఇన్కన్వీనియంట్
ఇది పాయింట్ సార్ సింపుల్ సార్
ఓకే
Okay. Okay. Very good morning to all of you. I am overwhelmed when our respected teacher read the progress card of my 42 years of professional career. It's really overwhelmed. I thank the Indian Geophysical Union and the selection committee and also the executive body for choosing me to this prestigious Dr. Harinarayana Lifetime Achievement Award for the year 2024. I'm very much thankful to this IGU and the members associated in the selection process. I think this award has started something about 10 years ago, and they have recognized 10 eminent earth science researchers in the country. So when I looked into the list, it started with the Dr. S.Z. Kasi, who was the leader of the first Antarctica expedition. And then next person is Dr. Devendra Lal, and so on. And among the last 10 members recognized, there are two important persons, and those two are my mentors also. Professor V.K. Gaur and also Professor Manik Talwani. I'm extremely happy to join the club of my mentors, of both of them and also another eminent people. I also take the opportunity to thank the Department of Geophysics, where I have been studying during the period 1979 and 82. And also, I especially thank the teachers who taught me the subjects like gravity magnetic methods, geomagnetism, paleomagnetism, seismic methods, well logging, and finally, integrated geophysics. Among all these subjects, I think Professor I.V. Radhakrishnan Garu has played a major role. Many of the subjects he taught me, our batch was very lucky, in fact. And he impressed me during my education student career itself. That's the reason I have chosen him as the supervisor for my PhD degree. I have practiced all these subjects in the professional career, and also I have added additional subjects. I learned additional subjects like stratigraphy, structural geology, geochemistry, geochronology, and so on. All these subjects, I put them together in understanding the complex geological problems. That's the reason I was able to provide a more comprehensive and more acceptable solutions to any of the complex geological problems. That is the reason the models proposed by our team, particularly from the National Institute of Oceanography, have been widely accepted all over the world. And in fact, some of the models are being used as the practicals in American universities. I'm very proud to say that. And with these remarks, I will start my presentation. So during the 42 years of research, I have worked on several problems and provided very important understanding, brought out the very important understanding, which was well received, well accepted by the global community. And here I'm going to present the research what I have carried out during the last 7 to 8 years. Because I don't want to go back. In the last 7 to 8 years, what I have done is I have moved from the deep waters to the continental margins, particularly the east coast of India and also the Bangladesh margin. And then focused on the sediment. Next slide. Focused on, we all know that there are two major river systems. There are the peninsular river systems and the Himalayan river systems. They started depositing, discharging the sediments to the Bay of Bengal for several millions of years, almost since the breakup of India from East Antarctica. At various depositional rates. So using the seismic reflection data and also the other geophysical parameters, we try to understand the depositional rates in time and space and also try to connect with the continental tectonics, how the tectonic changes that have taken place on the continent have influenced the river systems to bring the sediments to the Bay of Bengal. So this is the work basically I'm going to present. And also the continental margin of East Coast and Bangladesh, as we see the one geological unit, but it has different segments and it has behaved differently while detaching from the East Antarctica. Even that also I'm going to discuss here. And I try to be very basic level, particularly to reach to the students of the department. So here I have shown that the river systems have 6 major rivers that are carrying the sediments to the Bay of Bengal. And finally, we know that the Bay of Bengal has become the thickest sedimentary prism in the global oceans, almost reaching the more than 16 kilometers in the close to the Bangladesh coast. So for the benefit of the students, I wanted to present this slide, particularly for explaining the presence of the various basins along the east coast of India and also the deep waters of Bay of Bengal. So we can see there are rifted basins, the Kaveri Basin, Krishna Godavari and Mahanadi, and also we have a sedimentary basin in front of Bangladesh, that is called Bengal Basin. And there are 2 deep water basins, the Western Basin, that is towards the east coast of India, and the Central Basin, that is towards the Andaman Islands. Both the oceanic basins are separated by one of the very important submerged and buried 85 ridge that is lying in the north-south direction. So this slide also I prepared for the purpose of the students' benefit. This is a schematic diagram showing the crustal structure of the passive continental margins. Our east coast of India is a very typical passive continental margin, and it has been split from the Enderby land of East Antarctica, and it has been split and not associated with any magmatic activities. It's supposed to follow this kind of structure. So we can see here the continental crust, which has been attenuated and heavily fractured, and it becomes thin towards the offshore, and at some point it becomes terminated over here. And then other side, when we see the oceanic crust that has been formed by the mid-oceanic ridges, this is the incipient oceanic crust. And between the 2 bodies, continental and oceanic bodies, we have another unit, it's called the serpentinized mantle. That's because of the stretching of the continent, the mantle upwards, and then mantle rocks starts interacting with the seawater and turns into the serpentinized mantle. So this is a schematic diagram which has been prepared after making several observations on passive continental margins of the world. So we can see that fractured continental crust it is a thinning towards offshore, and then serpentinized mantle, and then oceanic crust tops. Then on top of the continental crust, we can see that there is a thin sediment deposits are there. They are called the syn sediments, and then on top of that, post-drift sediments, we can say that. These are the thin, syn-drift sediments. So that means during the rifting time, whatever the sediments have been deposited, those things we can see that they are just touching the crustal blocks, fractured crustal blocks, and continuing and terminating over here. But whereas post-drift sediments will keep on continuing. Please keep this model in the mind, and then we will examine the seismic reflections of the east coast of India at different places, how far they match with this schematic diagram that we will try to examine. So that's the later stage. I will bring the seismic reflection data. So before that, the team from the NIO and also the Professor Manik Alwani as an adjunct scientist to the National Institute of Oceanography, we have taken up one important problem, that is to examine the seismic signatures, or magnetic signatures, particularly the magnetic anomalies formed by the Earth's past magnetic reversals at two places. One is Bay of Bengal, that is close to the east coast of India, and other one is Andhra Basin on the East Antarctica margin, to find the similarities of the signatures between the anomalies. So here we compared, and the profiles from two different regions, we found the great similarities and also the matchable to the Earth's past magnetic reversals of something around 120 million years high. So we have identified the signatures both the side, and they are the conjugate signatures. We have used them. And also another one, we examined in the Andhra Basin, there are two sets of magnetic patterns have been identified. One is on the eastern side, we have identified with the fossil spreading center space of magnetic signatures, and western Andhra Basin, we have identified one set of sequence of magnetic anomalies. So keeping all these signatures in view, before that, also we have examined data available in the Bangladesh region, particularly close to the Rajmal traps and Silahat traps. This is the magnetic pattern has been presented here. So we can see this entire zone, it is providing two kinds of magnetic patterns. One is short wavelength magnetic anomalies, and other one is long wavelength magnetic anomalies. So both are having a different, both have been developed by the different sources. We can see very clearly that two sets of magnetic anomalies are existing over here, short wavelength and long wavelength over here. And also there are two seismic profiles. They have been shooted by the petroleum company. Those profiles have been looked at here. We can see that the fractured continental rocks over here, which are normally we see at the rifted margins. And also we have seen the CO taking reflectors, this green portion. So these are the indications of the breakup of continent from the another continent. So, but interestingly, these signatures we are finding right inside the continental regions. That's the important thing. Keeping these results in view, so what we have done is we have reconstructed the Indian plate and Antarctica plate at two different ages. That is M2 time. This is something around 125 million years. We can see that there are some microcontinental pieces. They were sitting very close to the east coast of India 125 million years ago. So one is the Elan Band, and there are the other two continental microcontinents. You can see that there is the southern Catalan Plateau and the part of the central Catalan Plateau over here. And at the time of 120 million years, M0 time, this is the time exactly the Kerguelen plume initiated the emplacement of the Rajmal traps and Silahat traps near the Shillong Plateau. And these microcontinents started detaching from the east coast of India and pushing to the Antarctica plate. Next problem we have picked up, that is to understand the sediment pattern of the sediment depositional pattern of the Bay of Bengal, and also, as I told that, to know the rifted mode of rifting along the east coast of India and Bangladesh. And here I show the profiles along which the seismic reflection data, industry seismic reflection data have been acquired, and the gravity and magnetic data also acquired by the GXT technology. And also there are east-west profiles that have been acquired by the NIO on Sagar Kenya. And this data we got it from the ONGC as a collaborative project to investigate some of the important questions relevant to the ONGC also. And there are two drill wells here, well A and well B, which has been penetrated the entire sediment strata and touched the basement. And we have used this wells information, particularly for assigning the ages to the different sedimentary layers identified in the seismic reflection data. So this is a typical seismic reflection data I'm providing here. You can see this is the sea floor over here, and this is the oceanic basement over here. So when we see on top of the oceanic basement, there are different sedimentary layers and very prominent reflectors also available. And we can see that from almost 120 million years to the present. And because the drill well information is available and ages are available, we assign the ages to these different prominent sedimentary layers. And this is the layer at 65 million years old, and this is next Eocene, and then we keep on continuing. Here, this is the Miocene boundary, 23 million years. So we can see that from 120 million years to 23 million years, this is the sediment deposition. It's not very much high rate of deposition. Whereas for the last 23 million years, 23 to present, we can see that enormous sediment deposition. It is almost twofold of the sediment strata which was deposited between the 120 million years and 23 million years. Also, I show some of the important pictures for inspiring the students here. We can see this is the attenuated continental crust after completion of the rifting. That means it is negotiated with the conjugate continental margin to detach. So during the process of detachment, definitely it will undergo the deformation. We can see the crustal blocks, the fractured crustal blocks bounded by the normal faults. And then also we can see this is the continental Moho boundary over here. And this continental Moho boundary is coming up. That means the continental crust is thinning. What I have shown in the schematic diagram, that is attenuated continental crust is thinning towards the offshore. And then suddenly we are finding a exhumed mantle, then the oceanic crust starts over here. And this is another continental margin model. We can see that it is also fractured continental crust, but it's a different mode when we compare with this model. And here I wanted to show because many times we discuss about the Moho boundary when we are handling the gravity and magnetic and so on. The seismic reflection data very clearly presents this is the oceanic basement and this is the Moho boundary. You see the cohesiveness of this boundary. It is having 6 kilometers from the basement to the Moho boundary. This is the entire crust has been imaged. And this is another section close to the Bangladesh. Also, we can see this is the oceanic layer. This is the basement, and we can see the Moho boundary is continuing with a slightly thicker crust over here. So these are the two drill wells I presented here. Basically, we have taken the information, sediment type information, and also the ages that correlate to the seismic reflection profiles, particularly to provide the ages to the almost entire western Bengal. So this is a profile on Kaveri Basin. So that means the southern side, we can see that this is the interpreted section over here. And also on the top of that, we have stacked magnetic and wave anomaly over here. So we can see that there is the continental shelf and continental slope, and then continental rise and keep on continuing. And this is the basement over here, this is the thick sediment strata. And this has been interpreted, you taking the drill well information, particularly ages from the drill wells. You can see we have identified this a faulted crust. And we can see that the normal faults are more dominated over here. And the width of the continental blocks are smaller, and fault throws are very extensive over here. And we have identified different sedimentary layers. This is the configuration we have to keep in mind when we move towards north, particularly coming to the Krishna Godavari basin. The picture has been completely changed. We can see that picture over here. Here, the fractured crustal blocks are more dominant, and normal fault throws are not extensive. It is very limited. You can see that. And the continental crust is thinning, extending and thinning towards offshore and north. And then this is the exuberant mantle and incipient oceanic crust. A perfect model to the global schematic model. Global schematic model, what they have provided. So move to the Mahanadi basin, a different scenario we can see that. So that means when we move from Kaveri basin, Krishna Godavari basin and Mahanadi basin, what is happening is in all the places we have seen the fractured continental crust, but in different modes, not the uniformity we found. And also the extent also it is different, offshore extent. In Krishna Godavari basin, it is extending a lot to the offshore, but whereas in Mahanadi and Kaveri basins, the extent to the offshore is limited, not too much. This is another profile I provide from the Bangladesh margin. We can see the so-called fractured continental crust is missing here. We did not find any continental blocks here bounded with the normal faults. That means the crust is intact and did not show any evidences or signatures for the rift process, and it is just continuing over here, and we found the different ages of the sedimentary layers over here. So that means I have taken the four representative profiles, one from Kaveri basin, is showing a different kind of structural pattern on continental margin over here. And we can see the Krishna Godavari basin, it is thinning and continuing to a larger extent into the offshore. And this is the Mahanadi basin, it has got a different side of rifting process. And in Bangladesh margin, it is completely opposite. We did not find any of the rifted continental crust signatures over here. Further, what we have done is we also have developed depth to the basement map to understand the basement configuration. How we have prepared is, we know that seafloor and below the seafloor, thick sediments are there, 8 to 16 kilometers. What I have done is, we have removed the 16 kilometers, 8 to 16 kilometers thick sediments completely, and then one can see the oceanic, one can see the igneous basement, it's a configuration, how it is behaving. And the second one is, we also have prepared a total sediment thickness map, and also we looked at sediment maps at different ages. Means once the basement is formed, from basement to the 65 million years, what is the sediment thickness, what kind of patterns are there, and from 65 to 23 million years and 25 to 6.8 and so on. So this map provides the basement configuration. We can see that very interestingly, close to the coast, depth of the basement is very less. And it's a keep on increasing when we are moving towards the western basin. It is increasing the depth values. But also, Also at some places, this shallowness is bisected and it is deepening to the basement, like a gravels they are presenting here. So we have identified 5 gravels, G1, G2, G3, and G4 and G5. Once we assume that in absence of the gravels, what could have been happened, depth to the basement, the shallow depth to the basement would have continued without any breaks, without any disconnect. But there are gravels present. That's the reason it has been interrupted the continuity of this shallow basement over here on the close to the coastal beach. What are these gravels? These gravels are nothing but the continuity of the river systems. What we see that G1 is nothing but the Kaveri river system is continuing over here, and then G2 is a structural continuity, and G3 is the Krishna Godavari gravel, that is Pranayita Godavari gravel is continuing into the offshore region, and the Mahanadi, this is the Nagavadi Vamshadara, and this is the Mahanadi gravel is continuing to the offshore. Very interestingly, these gravels are terminating over here. Their continuity we could not see beyond 125, 150 kilometers. They are terminating over here. It's a clear proxy or clear evidence that the continent is terminating over here. Because if the continent would have continued, the gravels also would have continued. Because the river systems are there on the continent, on land we are able to see, but in the oceans, the continuity we have seen up to 125 to 150 kilometers. This is an important evidence we considered for termination of the continent and then mantle upwarping, then incipient oceanic crust. And this is the total sediment thickness map I have provided in terms of two-way travel time and also in terms of the kilometers using velocities from different approaches. We can see thick sediments almost 16 kilometers presence or in front of the Bangladesh marking over here. Next question is, we know that there are two river systems, one is Indus on the Arabian Sea side and also the Ganges and Brahmaputra in the Bay of Bengal side. They are continuously discharging the sediments into both the basins, Arabian Sea and Bay of Bengal. It has been mapped their region to what extent these fan sediments are being reached. In both the cases, we can see the limits of these fan sediments, and in the case of Bengal fan, we can see going even beyond the equatorial region, up to the 7 degrees south. So this is the now that the extent of the Bengal fan sediments, but what is not known is when the Bengal fan started depositing the sediments in the Bay of Bengal. So that particular problem, we all know that Bengal fan, this river systems, Ganges and Brahmaputra are carrying the sediments and depositing the Bay of Bengal. And also from the various geophysical data sets, also we know that to what spatial extent these sediments are occupying. The third question is at what age this Bengal fan sediments started depositing in the Bay of Bengal. The question is not clearly known, although many of the experiments are being carried out by Indian researchers and also the researchers from Western world, from Europe and the US. This particular section provides, of course, this has the relevant information also, two patterns of the sediment depositions. The blue line is a boundary. It represents the 23 million years or the Miocene boundary, Oligocene Miocene boundary, which is separating the two sediment depositional patterns. Let us look at very closely that beneath the blue boundary, this interface, the sediments are just parallel in this interface. It's rising now. All sediments are following the same geometry of this interface what we have interpreted, that happened to the 23 million years Oligocene Miocene boundary. On top of that, you see that sediments the trends are totally different. They are horizontal, nearly horizontal, and they are coming towards the coast and onlapping against the one of the prominent boundary what we have identified. So therefore, we call this interface as an important unconformity, which is separating two different kind of sediment. The upper one is nearly horizontal sediment deposition. The lower one is paralleling the trend of the interface what we have identified. This is another section, also shows the similar one, but in a different configuration. We can see this is an interface identified, and then below this, you can see the sediment pattern is exactly following this same pattern. So that means up to the time of deposition of this boundary, there were no changes. It just keep on depositing in the same trend. But at this particular point, there is a root changes come, probably on the Indian subcontinent itself, probably on the discharge of sediments by the sets of river systems itself. That has been shown here, and different sediment patterns over. This is we have aged this boundary. This is exactly the 23 million years time, and also we interpreted this importance of this boundary is beneath the 23 million years, the peninsular rivers were very active, they were keep on depositing the sediments, and Ganges and Brahmaputra river systems were not existing, not discharging any sediments until the 23 million years. So 23 million years onwards, once the Himalayas have been set up and they have been grown to almost to the present status, and then monsoon system has been established, what has happened is the whole system has eroded the sediments and brought heavy sediment flux to the Ganges and Brahmaputra river system into the Bay of Bengal. So it started forming the horizontal pattern. And this diagram provides the crustal thickness, not crustal thickness, sorry. This is the sediment isopack map. What I have done is, we calculated the total sediment thickness up to the 65 million years back. So that means if you go back to the 65 million years, what is the thickness of the sediments? You can see that. So this sediment trend is basically, it is, so that means all these sediments have been discharged by the peninsular river system. Sediments started from northwest to southeast direction. You can see that all these things. And this is a 23 million years to 6.8 million years. We can see the depositional trend is completely changed. This trend, northwest southeast trend is completely absent over here. You can see here, northeast southwest is a different trend we can see. So that means 23 million years onwards, sediments coming from the Ganges and Brahmaputra river systems have been dominated significantly, and much more than the sediments discharged by the peninsular river system. So this clearly communicates that at 23 million years time is an important time boundary to show the different two different sediment deposition patterns that are happening up, and also to indicate it's a time for onset of monsoon system in Indian region. And this is a 6.8 to 0.8 million years sediment thickness. We can see that during this period, sediment depositions are excessive in the Krishna Godavari basin and also in the Bengal basin. And Krishna Godavari basin, because the sediments are excessively depositing in the last few million years, and they are supporting the presence of gas hydrate resources over here. Gas hydrate resources are not found so far in the Kaveri basin and in the Mahanadi basin. It has found only in Krishna Godavari basin. The reason is the required amount of sediment deposition is taking place in the Krishna Godavari basin. That's the reason it is able to trap the gas hydrates, so not allowing to dissipate the gas hydrates from the origin place. Whereas in the Kaveri and the Mahanadi basins, not sufficient sediment deposition is available during the recent time. That's the reason whatever is forming it is not retaining in the basins. So we have plotted here the sediment deposition rates for the last 80 million years, 80 million years to the present, and taking as the evidences from different regions of the Bay of Bengal. Very interestingly, we found, we started at 80 million years back, it's a very small rate of sediment deposition, that is 20 meters per million year. At 65 million years, we have found a big jump in rising that is going up to the 40 meters per million year. For up to 8 to 10 million years time, there was a sediment deposition rate was very high during this period. Then what has happened? Why suddenly there is a twofold of sediment deposition during this period, 65 to 56 million years? We all know that on the Indian subcontinent at 65 million years back, Deccan traps have been formed by the reunion mountain flow. So that means the elevation of the Indian subcontinent has been changed. Prior to the 65 million years is different, and after 65 million years, because of the emplacement of the Deccan traps for a wide region, almost the western region, northwestern region, that has changed the topography of the Indian subcontinent. When the gradient of the topography changes, definitely it impacts on discharge of the sediments. That's the reason the higher rates have been recorded. And then it's continued again slower rates at 34 million years slightly. There is an increase, that is the Proto-Bengal fan, and then we identified 23 million years phenomenal jump in the rates. This is the time where the Himalayan river systems, particularly the Ganges and Brahmaputra, started discharging the sediments, overtaken the Peninsula river systems. And then the situation continued and it's keep on increasing the rates at 6.8 million years, again increased, and even currently it has been much more deposition rates are taking. And these rates we have compared with the Ocean Drilling Program and also the IODP program results, which have been delivered in both the places in their Bengal and Arabian. Yeah, very well correlating these identifications. And also we prepared using this data, the crustal thickness and also the Moho boundary configuration. So when we see the crustal thickness, very interestingly, the thickness is very high, more than 30 kilometers along the coast. It is very natural that we are moving from the continent to the offshore. The continent is thinning. The thin continental crust, 30 kilometers, so it is thinning, keep on thinning, you can see. But interesting point, when we come to the north of Mahanadi Basin or Bangladesh side, the crustal thickness is not very much thick. It is very thin. It is 6 to 7 kilometers only it is showing. So please recollect back the seismic section which I have shown here. It has not shown any deformed crust over here or rifted crust over here. So that means this continental crust, the thicker continental crust following the east coast of India is going up to the Mahanadi and north of Mahanadi is terminating and not shown its trend against the Bangladesh mark, as if it is going into the continent itself. And this is the depth to the Moho boundary. You can see the depth to the Moho boundary is almost deeper along the east coast of India, and also offshore Bangladesh also deeper, not because of the crustal thickness. Crustal thickness is 6 kilometers, but sediment thickness is excessive. That's the reason we also find a deeper depth to the Moho boundary. So using all these results, what we have done is, the east coast of India has been rifted from the East Antarctica on a segment wise. The Kaveri margin region is segmented on a transform margin, and this is, and then hyper extended, then hyper extended, then hypo extended. And also this blue line shows the termination of the continents from the continental region. And coming to the, after reaching the Mahanadi Basin, instead of following the coastal region of Bangladesh, is directly entering into the Bangladesh and going to the Sri Lanka. So this is a boundary separating the continent from the other rocks. So in the Bay of Bengal, we can clearly see that these are the oceanic rocks, but in the Bangladesh region, at this point of time, it is difficult to say that what type of rocks are existing. within the Bangladesh. Keeping these questions as a challenging, what we have done is we have extended our studies to understand what is the nature of the crust lying beneath the Bangladesh. Because we have identified the boundary which is separating the continent that has shown entering into the Bangladesh. We were not ventured to say that a different type of rocks are existing in the Bangladesh. Then what we have done is we have continued our research to see further evidences to what type of rocks are existing beneath the Bangladesh. So we have taken, this time we have studied the region, both and ocean together to see the continuity of the features. So we assimilated the free air gravity data of the offshore region, that is the offshore Bengal Basin, and low air gravity anomaly of the onshore Bengal Basin. And then we presented this is the gravity map of the entire region over. We can see that the continent ocean boundary, which we have identified as the negative gravity anomaly signature, which is continuing over here, and instead of following the Bangladesh margin, is entering over here and going this significant negative gravity anomaly and taking a turn here, northeast turn, and going south of the Chilang Plateau. That's following the Dauki fault over here and connecting the subduction zone over here. This is the continent ocean boundary. You can see that. And also two important things. One is this one Ganges system, and other one is another system. Both have the Brahmaputra system. Both have the continuity, and they have the graben system over here. This is the Brahmaputra graben over here, just on west of the Chilang Plateau. It is continuing over here. And then we could not see its continuity further down in the Bangladesh. And similarly, we can see the Ganges river system related graben, which is continuing here on east of the Chilang Rajmahal traps, and it is terminating over. So we have seen the continuity of the grabens in two different styles. Peninsular river systems grabens have come to the coast and gone into the offshore, and whereas Himalayan river systems have not come to the coast, they have been terminated in the inside the land itself or this region. So that shows that our continent was terminated over here. The continent ocean boundary which has continued over here is continuing over here and then taking a turn over here. That's the reason these graben systems have been terminated, not extending further into the Bangladesh region. So we have used the gravity data for modeling the crustal structure, and this is the east-west profile. So we can see that this is the continental crust on the this one on a West Bengal side, and then this is the oceanic crust of Bangladesh, and this is the subduction zone over here. This is the part of the Singam Plateau. And in the case of north-south profile, we started from the Chilang Plateau. After the Chilang Plateau, suddenly we identified the oceanic crust, and then we can see here the Bay of Bengal, present-day Bay of Bengal starts over here. So that means this entire region was once upon a time the part of the Bay of Bengal. So we say it's a proto Bay of Bengal. It started, its boundary was adjacent to the south of the Chilang Plateau. So then we reconstructed using the gravity signatures and also the magnetic signatures. Then we found the presence of the microcontinents over here. There is no Bangladesh region over here. You can see that Indian coast, all the river systems are existing over here. North of the Mahanadi, it goes, coastline goes to the Rajmahal traps and also connects to the Silahat basalts. Here, these continental microcontinents are adjoined over here. At the time of 120 million years, there was no presence of Bangladesh here. And this is at 23 million years. Also, we reconstructed, you can see the boundary separating both the rocks, continent and oceanic. And again, it's going close to Rajmahal and the Sri Lanka plateau, and there is no existence of Bangladesh, even at 23 million years. 23 million years is a very important, I have shown the importance of the boundary in the seismic reflection records. 23 million years onwards, huge sediment deposition has taken place because both the river systems brought the material from the Himalayas and deposited first close to the existing coastline over here. The coastline was existing close to the Rajmahal Traps and Sri Lanka plateau. And it started depositing. But since 23 million years, over the time, the sediment prism has reached to the above sea level. Today, the Bangladesh is existing at about 10 meters elevation above the mean sea level. So all this research we have published in many of the papers. So these 5 papers we brought it out, published in Current Science, JGR Solid Earth and Journal of Geological Society of India, Marine Geology and Marine Petroleum Geology. Yeah, this is the time I need to acknowledge my organizations where I have worked. 42 years ago, I started my career working with the GSI, that's Geophysical Servicing Corporation, served as a seismologist for basically exploring the hydrocarbons in Krishna Godavari and Kaveri basins. And then in 1984, I joined the CSIR National Institute of Oceanography, served to the grade of chief scientist for exploring the Earth's interior beneath the Indian Ocean. So there my career has been changed totally, and National Institute of Oceanography has given a freedom and great opportunity, and it became a challenge for me to put all my intellectual power to understand the complex geological problems. Concurrently, I also served as the professor in physical sciences and senator for ACSIR for about 8 years. And then in 2017, I joined the University of Hyderabad as a professor and head just to oversee the academic and research activities at the ocean atmospheric sciences. And then in the year 2023, I joined the Geetham University in Visakhapatnam campus for serving as distinguished professor and also the Dean School of Science. I take this opportunity to thank many of the people who were with me during my journey. And you can see that there's my supervisor along with the Professor Radhakrishna sir, Dr. D. Gopala, and also my student, my supervisor and my student and my colleague over here working on the seismic sections, particularly identifying the 23 million years important boundary. This work was carried out in Dehradun in the midnight 1 o'clock. And these are my other students working for the PhD, postdoc, all these things. It was a very healthy interactions and discussions for various models, what are the problems, what are the shortfalls in the models and so on. And this person is now serving as an assistant professor at ISR Pune, and this lady is working as an assistant professor at Pondicherry University, and this boy is continuing as a BSc student at Polar Research Institute, Goa. And this is he produced a landmark paper for the tectonic origin of the Bear River in Bangladesh. And we can see the stalwart of the marine geophysics of the world, Mani Talwani. It was a great opportunity for me to work with him for almost 3 decades. And I learned a lot from him. To be a best researcher in the world. He taught me many things. And he passed away in 2023. We have written the personal news about all his achievements and his phenomenal achievements. Thank you very much.
Thank you, Professor. The speaker staff for a wonderful talk. The 23 million which you have mentioned, I think is now going to make a bigger mark in the climate change. So I think on the present day concept of climate change is everything that largely of the climate and the entire village. Thank you very much for a wonderful talk. And then now we come as for please.
So you have mentioned okay.
Very quick, but
Yes.
So there are two epochs over there. One is 53 million years, 5 million years, and the other is 23 million years. So do you think the rise of the Himalayas was the cause of the monsoonal system, or which is globally? That's my first point. And the second point, yeah, and the second point is, did the Himalayas rise, fall, and again rise? Because see, the system, what you are claiming is, if you are completely relying on the paleomagnetic data, and also do you have any
Seismic.
only seismic? What is the age frame you are talking about? I'm talking about, did you look into the radiometric data or only seismic?
Seismic data we collect to the critical information. From there we got the biostatical indicators.
But you have the build course what you have taken.
Yeah.
Did you take the radiometric data as
Yes.
reference?
Yes.
So the thing is, at 23 million years and 52 million years, why do you see this big difference? Do you think the Himalayas have completely fallen down, and this is the reason for the rivers have completely changed the patterns?
See, if you look at the plate tectonics of the Indian Ocean, if you look at the plate tectonics of the Indian Ocean, the Indian subcontinent collided with Asia something around 55 million years ago. And then hard collision took place around 45 million years. Since then, this mountain range started rising. So maximum rise it has reached the 23 million. So that's the reason it started interacting with the atmospheric circulation. Started interacting with the atmosphere. Until that time, it has not shown its influence in the atmosphere. Because it's supposed to have certain level of elevation. Then only it can influence the atmosphere. So at 23 million years, it has reached the almost whatever the elevation we see now, but there are minor changes. But after 20 million years are all minor changes. But before 20 million years, there is a rapid growth.
Yes, sir.
thank you very much. I think, sir, maybe we will.
Okay, just one thing.
Yeah, please.
I say, right, 53 million years, whatever you are talking about, is coinciding with the Oligocene Miocene.
Yes.
Seismically, that is important. Is it related to any global event? Because at the end of Miocene, at the end of Oligocene, there is major transition took place over the globe. Is it coinciding with this same event with the year? Have you observed in that?
I don't know the global event, but this event is related to our Asian region because these monsoons are limited to our regions only.
Yes.
So the establishment of monsoon at 23 million years has shown the changes in the sediment position that we have seen. This we cannot attribute to the entire globe. But why it is happening at the same age is maybe the different reason as well.
As you told, while answering him, that sea level changes are also occurring at the same time.
Yeah.
Major transition has taken place.
No,
And
sea level
is equivalent to the global event. This is why
sea level changes may be there, but that will not bring this much huge difference of sediment.
Thank you very much, sir. I think we'll have a lot of discussions during tea break. And let us give a big hand for a wonderful talk. Because as I said, we have got a lot of discussions where we talk about climate change and so on and so forth. So this becomes the basis for all this. Thank you very much. So may I now request Andhra to formal vote of thanks, please.
Thank you. A very good morning to all of you. On behalf of Department of Geophysics and my own behalf, I am proposing a formal vote of thanks for this IGU Dr. Harinarayan Lifetime Achievement Award lecture. Firstly, hearty congratulations to Professor Sri Krishna sir for getting this award. So we extend our special gratitude to Professor K.S. Krishna sir, Distinguished Professor, Dean, School of Sciences, Geetham University, Visakhapatnam, and alumnus of our Geophysics department. Your lecture is truly inspiring, sir, and motivating, sir, especially to our younger geoscience community. Thank you, sir. We express our sincere gratitude to the President, Secretary, and Executive Council members of the Indian Geophysical Union for arranging this IGU Dr. Harinaran Lifetime Achievement Award lecture by Professor Sri Krishna, sir, at our Geophysics department as part of Platinum Jubilee celebrations and national seminar. Thank you, sir. Our sincere thanks to Professor P. Rajendra sir for his support and encouragement during this entire event. We express our sincere thanks to Dr. Prasad sir, Organizing Secretary, IGU, for coming all the way from the CSIR NGRI, Hyderabad, and arranging this lecture at our Geophysics department. Thank you very much, sir. Finally, I thank all the professors, geophysics alumni, scientists, researchers, academicians, students for your participation. Thank you. Thank you very much, sir. Please, sir.
Sir, 1 minute.
Yes, sir.
1 minute, sir, please. A small felicitation program now. After that, we'll have a tea break, sir. Okay. So I request Professor I.V. Radhakrishnan, my guru. Yes. So Chetan Anand, please. So actually, please listen all of you, please. So Mr. Chetan Anand, our alumni of this Department of Geophysics, who renovated this program, that is hall, seminar hall, exclusively by him.
Very helpful that I am in this position because of all your teachers get. So the basics you have put it.
On behalf of our faculty, Department of Geophysics, students and all, we congratulate him and appreciate his service to renovate our Platinum Jubilee Hall or Silver Jubilee Hall. Total investment will be given by total investment. Really great. Yes, thank you. So please, IVR sir is participating in Thank you, sir. Thank you very much, sir. Next, yesterday, we conducted a number of sessions in which one of the chair here, Dr. Patro Garu, please come over the dais, sir. Please come over the dais. Yesterday, we missed it to felicitate him, so that invite here, please. No. Thank you, sir. Now, my guru, my thesis guide, Professor NVPS Prasad Garu, actually was due to various works, he was not attended yesterday, day before yesterday. So he came over here. So kindly, our Professor I.V. Radhakrishnan Garu, illustrate him on behalf of our Platinum Jubilee celebration. Small. Yes. Now, Professor I.V. Radhakrishnan Garu is illustrated by Sir. Please. Sir, that's different. No, this is different. This is Sir Krishna Garu. Sir, please, sir. Other sound. Great honor for great honor. Okay. Sir, please give you. Master Ramanaga, ఓకే రమ్మనండి
भानुप्रकाश आप प्रोजेक्ट అక్కడ అక్కడ
Sir, కొద్దిగా
Good, thank you. Yeah, thank you.
Thank you.
Tea break after 5 minutes. You listen after 5 minutes here. The event is actually not after 5 minutes. Please, please. 5 minutes.
they might be most experienced than me, or they might have already all this knowledge what I am sharing here.
No, not that.
Yeah, I think so. Because, but I think it would be beneficial for the students who are hearing for the first time. That is the reason why I have to share, but I respect the seniors and I have skipped a lot. And they said that I have skipped a lot of things. Difficult for me again to gain my momentum and this. I think department professors and head of the department should sit here. And I am inviting for special talks. Okay, I will continue. Yeah, this is one again. I have shown you regarding the airborne geophysical data, and this pertains to the heliborne geophysical data. So, heliborne geophysical data. When I say heliborne geophysical data, you know that as I have shown you the beacon configuration, we fly at a very low heights of 80 meters, and the helicopter speed is 80 kilometers per hour. And entire the system, the transmitter, coil, and receiver, they are under slung operations. So it is a very difficult task again, and we are flying at 200 meters flight separation. And this is parts of Kalahari Basin. The Kalahari Basin is again an important Proterozoic basin in India, where we do a lot of other mineral deposits. And this map gives a lot of information. This is the magnetic anomaly map, and this is the final map of a lot of corrections here. And here you can see the sediment thickness is interpreted from the magnetic data. You can see this scale here. The lot of sediment thickness is interpreted from the magnetic data. And basically, why we have known here is you can see the green portion. This is a lot of Deccan trap cover is there. So we actually want to know beneath the traps whether any sediments are there. And that is the reason why we went for heliborne geophysical surveys here. And we are lucky to find few areas where the Deccan trap thickness is very less, and we are able to see the signature of the sediments beneath the Deccan traps. So that is one of the important outcome of this surveys. And heliborne magnetic data is not just heliborne EM data. You can see here heliborne EM data involves a lot of processing at every place. We have to get the statistics right, and we have to do EM compensation, lot of filtering, and EM leveling. So after that, we have to do a lot of steps ultimately to derive any information from heliborne EM data like dBB by DT images, dfield images, because as you know, EM data it decays with time, and lot of channel data, time channel data is recorded here, and we do anomaly picking, decay constant, conductivity depth images, and show here some examples. Again, this is pertaining to this Mohr control. You can see how beautifully the conductivity isosurfaces were derived of the control. This particular part, Mohr control complex, the conductivity isosurfaces are being derived from this electromagnetic data. It clearly shows the depth extensions of the cauldron up to 300, 400 meters, up to what depth we can look. And this pertains again to the Kalahari Basin. Here again you can see here, this is the conductivity depth images. This is the base of the Deccan trap. So the Deccan trap thickness has been picked up, is around 100 meters. And where there is no trap cover, we can see this sediment extension up to 600 meters also. The signatures of the sediments are picked up. And these are the Voxel 3D models that we generally prepare. Then gamma ray spectrometric data, again, it is a very important aspect when you are looking for atomic numbers. We do a lot of things here. These are the few important steps like cosmic and radon background removal, stripping, height correction, and leveling. This has to be done very carefully on airborne gamma ray spectrometric data. And you will be surprised that a lot of geological information is hidden in this airborne spectrometric data. So we can clearly see the segment contact and the blue portions and the green portions, white portions. They give you a lot of information. Here again you can see this is a more cauldron, and you can see a hidden cauldron that is not there on the surface geology that have been brought up on the surface. Lot of ring dikes are there. Then this is the hidden cauldron that has been not exposed on the surface. This is exposed but not this one. So such type of information comes from airborne data. So coming to the end, there are a lot of advances in airborne geophysics. You can see now lot of gravity surveys are being done along with gravity gradiometry. Then there is particularly airborne JETM and empty surveys. The empty surveys, which are very difficult to be conducted on the ground itself, now they are being done from airborne platforms so that we can get the information up to more than 1 or 2 kilometers. I think Patrasada has explained in his lecture. And we are doing this in airborne ZM and empty surveys. We have particularly done airborne ZM surveys in Kratha Basin. So again, these are the two important things that you should remember when we are processing the data, because geophysics generally lands in physical property model, and the important task is how you convert that into rock type mineralization and alteration information. There are two ways of doing it: empirical targeting and conceptual targeting. Empirical targeting, I mean that when we go from known to unknown, that is empirical targeting, and when conceptual targeting, we should know the mineralization processes, and we should try to develop a physical property model based on these mineralization concepts. So ultimately, we should have the rock physical properties, and it should be used in constraining your inversions. That is the most important aspect of any inversion process. So this is how generally different steps involved in the mineral exploration. Then coming to AMD, we are having few programs that have been lined up in future. So we are planning to have unmanned aerial vehicle drone-based surveys, then the digital core scanners, then vehicle-mounted multi-parametric borehole warning systems, and the 2D, 3D seismic surveys, magnetotelluric, audiomagnetotelluric. This instrumentation part we are going to develop. So this is the summary. Airborne geophysical surveys play a very important role in identifying the concealed mineral deposits with effective and efficient integration of the data from all the other geoscientific data. Airborne geophysics are effectively applied. You can see what are the different parts that can be integrated. So we should reach to deposit footprints in the end. Thank you.
Thank you, sir. It's very really, I'm thanks for sir to give, and it's very difficult to run through all the slides. And really thanks. I think he'll be coming back. So now I request our next lecture. Yeah, Dr. B.S. Prasad sir to come on the dais and deliver his lecture. And again, request my sincere request. I think from all. I hope you'll understand. Because he's my sister. We are on the same ministry, Bishop.
Thank you. First step, I would like to. In the first step, I would like to thank Professor Naidu for inviting me to this. And I share greetings to the alumni department of Geophysics. That will be okay. Next time,
Small technical problem. I invite Dr. P. Venkatesh Naga.
Hello. Good evening. Everybody. I don't want to take the allotted time as well. Around 50 plus slides. Let us since yesterday or even before. Normally, I take this joke, please take it as a joke. Whenever somebody is talking geophysics about the water, they are taken very lightly. They are always interested in the $1 billion seismic industry, even mineral industry, and so many other things. But when the water comes around, my own colleagues say, who will go into listen about water? Yeah. Basically, this is the one which refers to, it pertains to the hydrogeological and geophysical characteristics of the aquifers of the north parts of eastern parts of India. That means we all see these eastern ghats where this chondrolitic rock is prevalent. In fact, the buildings of these institute is built with the chondrolites. You can see the rocks there. I am talking about the aquifers derived from these rock masses, and this physics is even I should say we call it as a near surface geophysics. In fact, it is a really near surface, very near surface geophysics. I mean, in the morning lecture we talked about billions of years. Now we talk about very small, there are 40 meters, 30 meters geophysics. See, first of all, you know how much groundwater you are drawing from this earth, around almost 1,000 meter cube. Unfortunately or fortunately, we don't know. 1/4 of the total world drawn groundwater is only from India. Only from India. 30% of our protected electricity, produced electricity, just only to pump the groundwater. Imagine how much groundwater we are pumping. This is the kind of pumping we are making. And to your surprise, India is pumping so much groundwater. Even if we put the America and China put together, we are pumping more groundwater. So this is the one which we have to think before pumping, and we have to learn more about this resource to manage wisely. This is very important. To do that, we have to know the physical properties of the aquifers. Particularly, this I have made particularly for the students. Since I have been working on the groundwater for the last 4 decades, most of the work which we carried in 90s, 2000s, and then after one by one. So
Condylite shoot, it's basically granite ferrous silicianite, you know, many of your. These are basically hard rocks, belongs to Precambrian group. The eastern Ghats of India extends all along these combined districts of Srikakulam, Vijayanagar, Visakhapatnam, East West, even up to Krishna also, this goes on, even in the Odisha state and so on. And of course, I just so you can see the monolithic rocks are not to the scale, not perfectly. In fact, I have worked in this basin. This is called the Kandivalsa River Sub-Basin, where there are some typical problems encountered. Some of our colleagues are here in those who are working. So, first of all, let us do the earlier geological origin of condolites. The farmer Prabhakar Rao, they said basically that sedimentary in origin, and Krishnan, they said metamorphism of sedimentary rocks became a hard rock. So, typical condolite is a rock constituting sillimanite, garnets, feldspar, and quartz. The main condolite rocks are associated with charnokites and observed to an intrusive character. But hydrogeologically, the very first, the greatest luminary of Andhra University, the Mahadevan, perhaps he was probably first person, the problem I have taken up to define as early as 1929. He says this chylonization problem, chylonization of the aquifer. So, scientists postulated that hydrogeolous concept of this region and pointed out that due to the action of water, the altered changes into a lateric soil and in the subsurface formation when acted upon by water alters itself into kylite. Whenever you drill a well in this region after the soil and then a whitish dummy like paste will occur. That is a kylite. Okay. So that is the problem. It almost appears like aquifer, but it does not. It does not yield water. It have some water. So the further hydrogeolous concept is from another great luminary of this department has worked, and core layer system, and of course, and I will see what this is. It is noticed that whether the increase, normally what do you say whenever you go for exploration, whether and fracture depth increase, more yield we expect. But in the condolites, yeah, the weather depth increases means there is susceptible for failure of the well. This is because the chylonization of problem. Kandivalsa River, you can see the normally we expect that near the streams we have a lot of water, feeling that. But what is happening is near the streams, this entire aquifer become chylonized, producing less water. Only the top uplands here, where the fractured layer thickness is maximum, it is giving more yield. If we go on proving it various studies now. So you can see at one of the same basin, this is one stream and the stream and stone. And below these two still here, this well. And then you go to near the stream, fracture thickness is decreasing and the chylonized thickness is increasing. This is what we have observed. So the aquifer resistivity is almost which is varying from. Suppose if you take the fake wells and then success wells, somewhere if you take 25 ohm meters to around 65 ohm meters. Beyond that, it will have a basement characteristic, and below it will have a chylonized characteristic, like a clayey type. So percent success will various topographic positions. I have shown mostly flat uplands are more successful. Percentage success rate is more. Middle slope is a little bit more, but low lying areas, particularly I am talking this for more wells, but not for open wells. Okay, the open wells will have collect some water, but less yield. This entire literature based on developed in those days, if you to drill wells, 8,000 LPH minimum required to finance the well. Otherwise, we cannot. This is for irrigation wells that you keep in mind. So, like that, the yield might have been reduced due to various reasons, including of fractures with the light. Investigation have also shows that the wells are located in quartzization. As you walk on the surface, the quartz pebbles appear, the quartzization, and the quartz veins, wherever they are integrated with, there are no number of success wells. You can see on the surface, you can observe the quartz flow is there, then first success is high. So with the 1D electrical, normally what you have for a simple hydrogeologist or a geophysicist, they have a resistivity meter, they do some sounding and then interpret and then recommend some wells. But many times what will happen, this type of procedure, some places successful, at some places identification of chylization is a problem. That is the thing what we do with. Some multi-geophysical techniques are employed. Let us see how, and like this, the knowledge has been gathered. We have developed, because when you go to the field, whatever the data that is available on the surface are accessible, whatever the observation you can make, that only the one which can decide the potential. So what we did in those days, the first layer resistivity, which is representing the quantization of the surface, and then aquifer resistivity as it is, whether it is a proper range or not. Even the basement resistivity defines how much its basement is weathered or not. The more the basement is weathered is going to be a failure. So this is how some geomorphic parameters, geomorphic unit, lineament control. In fact, near the lineament, it's a more failure because they are all lineaments are aligned in the streams. So that is how it has come. So based on these various knowledge base, we try to put some kind of model, which is earlier you might have seen drastic, which is used for pollution potential of the groundwater. Same thing, groundwater potential index like the weight into rating. For every parameter, there is a weight decided by the expert, and then the rating. Rating is based on just now you have Yeah, you can see here the ratings and then weight. These weights are decided by the expert based on your experience or group of experts. This is the rating based on purely on the data. So like that, this model we can work out, and the index has been computed, and this is the range of GWPI and the success wells. As the GWPI increases, and the more number of success should achieve. In fact, we try to change the weights with the other combination. The most successful weight combination has been achieved, and when you plot percent success and the range of groundwater potential index, then it will be a good correlation. Suppose 75% success if you want, that means if you require 10 wells, 8,000 LPH will be definitely yielded by at least 7 wells, or if we have a 35 to 37 groundwater potential index. This maybe in the first day they were talking about artificial intelligence. This kind of knowledge base would go into the computers. Any number of parameters you can put it, and then you can decide whether that well is going to be success or not. Another thing is some statistical modeling also has been carried out. Some parameters were selected: aquifer resistivity, aquifer thickness, depth through geometric basement, longitudinal conductance, average longitudinal resistivity, all these things. Some Dar parameters also you call. Then transverse resistance and so on. So, and we have subjected this entire matrix into a SysTag program, and the most successful cluster properties, geophysical properties, has been evolved. And this is how, out of all the parameters, this aquifer resistance is the one which is consistently giving, is the one, and also transverse resistance. Sometimes, what will happen, similar sounding looks like, but unless you compute these parameters, it may not be a different. So this is another way of checking. Next thing is, some very close with the different geological places, we agree there is a success and failure we can recognize. But within the same geological chapter, within tens of meters, the success and failure of wells occurs due to this kyanization. You can see this is a village name very nearer, maybe hardly less than 100 meters. These soundings are same, almost, even the resistivity parameters are same, but there are three pairs we have identified and then try to investigate it. First, we have applied shallow seismic thinking that this kyanization layer will have a different velocities, but unfortunately, we didn't get consistently like that. There is a problem in identifying. Similarly, the very low frequency electromagnetic method, they have given at one direction, east-west direction, north-south. At one direction, they have given another direction. There are current densities. These are. So similar such attempts are being made with various kinds of techniques. This is a upper industry polygons, successful, failed well, not much difference. Then our 3D and 2D resistivity technologies have come later on. By 2000, we could purchase these things, and these are applied at this particularly pair of success and failed wells, very near. The investigations, of course, all of these things these are how the kyanized layer has been mapped. At each well, success well, 3 parallel profiles were taken. Failed well also 3 parallel forms were taken with the intention that we create 3D model. So like that, vertically we went. These are the vertical slices up to 70 meters depth. The inversion can go. So at a failed well. So let us go this integrated into slicer dicer software. You can see success well. The kyanized thickness is less, and this is the most fractured thickness. Whereas failed well, the kyanite thickness is more. So like this, most of the cases, similar kind of things. Here is a complete kyanization of the total aquifer. So we could identify 3D block images. Okay. Then this is another pair. Same is the case, complete kyanization. Which that means what is the difference? We could gather more data very intensely at the scale of 1 meter or so, or 2 meters. Invert the data, then we can distinguish the things. That is the thing. And of course, these are the same thing converted into numbers. And I will avoid this. So, what is the findings from this 2D and 3D image has given more insights. In success wells, you can see kyanized depths are more in terms of even more than 20 meters at some places. And at failed wells, kyanization is not only deeper, but basement characteristics immediately occur. There is no active good yielding water. There is nothing like that. At success wells, not only kyanization layer is thinner, but also the aquifers are thicker. So these are some of the things. Then IP chargeability map, along with the resistivity, you can also just put on the IP also, measurements you can take. You see, with the intention that this is the concept. Telford and others have found that kyanite and shales with high percentage of clay minerals have relatively low polarization and lesser chargeability. So here in our case, the kyanization should have lesser chargeability, and the fractured rock will have more chargeability. That concept has been applied, and we have seen almost the layers having high thickness of obtained at greater depths, higher chargeability values. This is the range where this kyanization is telling. Chargeability is higher, 1 to 3.58. Whereas in other cases, the fractured rocks 0.25 to 1. So this is how we can distinguish, and same concepts we have tested by observing the transmissibility and the storage coefficients also. And you can see this is the range of transmissibility and storage coefficients of the wells. Minimum of less than 100 to a couple of 100 transmissibility storage coefficient are like that. But you can see this is the mainstream. The storage coefficient, on either side, the more storage of water compared to this mainstream. So same is the transmissibility. This is the concept. And this is the recharge we have estimated from annual rainfall around 11%, 13% like that recharge is there. All this went into the groundwater modeling and steady state, unsteady state groundwater modeling also has been done. You can see computed and actual observed contours of the water levels, they are matching. So you can see the first layer, chylized layer, varying from 1.6 to 1.9 meters. These are the physical properties we can, and the second layer, the varying from this hydraulic conductivity 1.8 meters to 2.6 meters. Similarly, we have logged the wells. What are the properties you can see? The chylized material is a risk, particularly lateral resistivity is of the order of less than 25, whereas the aquifer showing more than 25. The original surface resistivity also defined the same thing. They matched with the well logging techniques, and the porosity is of this order 18% to 20. This is something misnomer, that is not correct. 14 to 26%. Almost in the porosities, there's not much difference, but only this conductivity and all is a difference there. So these are the conclusions. Already my time is over. I need not emphasize. This is the all the and number of papers were published. Many in. Okay, thank you very much.
Thank you so much, sir. Dr. Venkatesa Ragaram. Have given a very nice lecture. Time is very precious to us. Any questions? One question, please. Only one question. Any? Okay. Then we shall proceed further. Thank you.
We are going with the first lecture with Dr. V.S. Prasad from National Center for Medium Range Metascope.
Thank you. Sorry for the. And I will take this not with the picture because then this no problem. First, I will congratulate all the alumni of the Geophysics. And last 2 months back, I am from the department, alumni from the Department of Geology and Oceanography, and I did my PhD on issue of potency. And at present, I am working as a director at CMOW, which is the premier weather modeling center for the government of India. And I take lot of sciences and also my center what we are doing that vertical forecasting. And this activity which weather modeling is important for the utility applications. Now, it is already giving support to the other renewable energy and all GS type on the land side. Our artery up and it is now included in all the Geophysics and we are giving special forecast for the DGRE for land side forecast and also the allergy forecast. Actually, so this is the sciences. We have the two process of the component of this. We have the department, other than and one aspect is of IIT and Jubilee, all three for the technology and other centers mainly deal with the water and another center is the LTPO, the Geosphere and and we have the employees for the national service for the ocean information and like MOA is working for the cause of the coordinator. And this is one of the only institute of ministry in the world have a specialty for meteorology and sciences. So at NWP, we have the global model for giving the forecast and weather forecast for the different application, different resolution. For the city, we are giving the forecast. We are giving the forecast for the city level forecast for the air pollution and also for the I got flood applications, etc. So these capacities we have all giving the weather forecast to the whole application of the road that go and display it and run numerical model and then do the forecast. So what comes weather model? Because the students are here who have introduced I want to introduce about what is the weather model and what is the climate model. What is nothing but our weather model or climate model, these 5 equations and solve with partial differential equation. And we solve this equation at the next step and integrate it for the result. And for doing so, that is by the dynamics, in that all the physics are included in that. The radiation system there, and also what are the motions and what are the motion, and also all human influences and atmospheric gases and volcanic activity. All these things are parametric in the model, the physics of the model. The dynamics and the physics together, all the things are we estimated we put in at system model and use the resolution is the what is the latitude and longitude by how much area it will cover. That is the resolution of the model. Depending on the resolution of the model and also using the various physics parameters, complete process. All you know the atmosphere and ocean are continuous. It is not at a single point that one. So we have to process all the physical laws every complete process to parameterizations. And the parameterization are process of the model. As I said, all the parameterizations are there for the model is completely together weather and atmospheric. And if you give initial conditions, if you ever update the model and give the present conditions, next if you hours per day, you will get the initial forecasting. If same model, if you use the seasonal climate and the climate change, put that one, you get a climate model. Use that can be boundary conditions, you get the climate model. So the same model can be used for the weather and forecast and depend upon the state. When you are giving the forecast, it is called forecasting up to hours. And if you are giving the 3 days, it's called the short range forecast, and 1 week up to 10 days, medium days. Depending on the scale, depending on the model resolution, give the different forecast. The subsequent forecast for 1 month, the seasonal forecast for 1 month. But various forecasts, what we predict is dependent upon the quantity that you exact in the low-casting and exact quantity. That is what is rainfall. When you are getting a fall or rainfall, that will go in the low-casting system. And the seasonal and sub-seasonal forecast will give the tendencies. Whether the next few months or week it will be or it is going to high temperature. That type of forecast are there. And now the climate model, WPCN, sea ice and ocean circulation, these are not included. When you include sea ice and land ecology, atmosphere, everything, it will be a system. And our sister organization, IITM, is a system model, and now we are and this system model, when you are changing, when you are changing only range and carbon dioxide water, it is in 1970s, the climate change certificate. Actually, now all the things are included and one by one, and now we are doing the AR4 model with what you are telling. Then you are getting the chemistry also included, and interactive education, everything. And now, gradually, our understanding the model, I see CMX 5, CMX 4, like that. Now, AR4, we are giving all the chemistry of the model and the interactive biogeochemistry, biogeology, and also the cloud, the full system. And as soon as our understanding increasing, we have the different scenarios. And these scenarios, with these things, you can see the, if you see the climate risks, you can say, you will see the trends and the climate changing. If you see from last 2008, you see the carbon dioxide and ppm is gradually increasing. And these things in your climate model, and you can see how the global sea level is rising, ocean warming. Actually simulate and what you are getting ICP reports and your climate change report. And these things we use for you now cash to be with the high resolution, you get the weather what you are getting you are and weather forecasting when the anti model was started in 89 when the time we are using the 150 kilometers. You see orography, this representation of orography, the weather model. Earlier, what we started is the almost Himalayas looking like kilometers. And gradually now we have the 12 kilometer resolution. They are orography. So you can simulate more realistic things and our forecast probability. Now it is reaching 6 kilometers. This is made possible because is made possible because we have a higher computing power. When we started, it is only 6 megawatts of system. Now we have recently Prime Minister Modi inaugurated Dr. Steven 22 petaflop system. It is the fourth highest in the world, and now we are getting forecasting modeling. We have high resolution model with Arlika and Arca, 22 system is there, and also the observations. We have started getting observations from the satellite data is coming. We give the data from the human test and also know all the data being received, and volume of the data is increasing. And we have our own satellite program. India is one of the few countries. Both the fifth country is having the NWT program as well as satellite program. We have our own satellite sensors starting from the INSAT series. INSAT 20 onwards, we have our own launch and our own Indian technology. So we are all the satellite programs are designed for the technical one and OceanSat 1, Kalpana, Sat 3D, and now recently Sat 3DS. All these satellites we are able to design, launch, and disseminate satellite data for weather forecasting. And that's why using all the data and the improved modeling of weather forecasting, which are improved. Now our forecasting skills are almost equivalent to the second to none. We are getting high resolution resolution data, and we are getting improved physics. We are able to do the weather forecasting. That's why you are dealing nowadays in increasing the quality of the forecast of our national weather service. The backbone support is coming from services. And at present, with the new system, we have all the things. Coupled model we are running it and going to run from this. Not only atmosphere, we have the oceans and also sea ice and land data. Everything is coupled. Coupled atmospheric models, we are running that one. So these products can be used for forecasting as well as other applications also. And we have so many users starting from for studying the lightning, and we have the cyclone, heat wave, dust, special products are there, and we have all our users from the not only weather forecasting side, we have the forecasting. As compared to this particular workshop, we are giving the forecast. See now, India is going to be renewable the Prime Minister program. In that, very wind farms are established, see the solar farms are established. The major problem for them is they have to forecast next 24 hours how much energy they are going to produce. They have to if they are not able to produce, only the range is given only plus or minus 10%. Here, not a business, commerce is involved in that one. If they are not able to produce what they projected within 10%, they will be fine. And if you produce more than the 10%, they will not give any money. They will not get any money. So they require a very accurate forecast with the solar energy, and that also required every 15 minutes, and they are publishing that one. And AGSEEN have started pushing the data to all of them, and within 50%, we are giving the forecast to all of them, and all energy sectors are using the data, and they are paying for this service. That is the quality of the forecast that close, and all private sector energy companies, they are borrowing money and able to predict the forecast, how much they are putting. So, and also to study the how much potential is there to establishment that one. We have run the DNR for 40 years, and 40 years DNR data is there. Maybe our data is our fluxes and all energy is stored, and that we use it for giving the for developing the new forms, and so the private sectors are using the DNR for the establishment and also for the revenue forecast they are using that one, and giving better forecast than they are having. And so many users from the private sectors are using the thing that they are paying for. And the next thing what we are giving, that's that GSA established the landscape and the water system. For that one they require rainfall and the area. All areas are identified, but have in the rain and landslides that we predicted very well with this thing. That depends on not only today's rain, current rain, it should have the history of next to last 1 week, and this how much rainfall occurred, and what is the soil and soil moisture there in the area. So this for this sector also we have the worked on that with GSI, and we are able to give more accuracy. If you are given the deterministic single value, all models have uncertainty, but the user have applied the uncertainty also. For that, we are now developing ensemble model. If you apply the single model, we are learning a particular number of like that. Two systems are 42 ensembles are available. With this ensemble, we are comparing that what is the output. Suppose 90% they will be more, and if it's 1% they will be, and also the variation is not that you will comparing that. They are able to predict landslides and also and the examples where the landslide prediction is available, and we have communicated we are able to show that weather forecast, not only for the weather sense, but with the weather, what is the molecule. Says that one for all other parameters, energy, landslides, and also avalanches, we are able to support this system. And things are very well established. We are get able to do that one. So we have signed MOU with PSI for the internet. And also, the same forecast we are giving heavy ship movement and polar pressure also forecast we are doing there. And with our forecast, heavy augment, supplement, yeah, that one also original diameter forecast for that one. These are updated, available, and we are proved that one, and we are now giving the forecast improvement. Okay, now we are working the kilometer scale, 5 kilometer model that developed. I'm giving the accurate forecast of that thing. Every hour, to catch the institute development and the global simulations. other community for geophysics, snow avalanche, and also landslides and all other applications.
I would like one doubt from, yeah, sure, sir.
So now, and I have got that. Now, for that purpose only, we government mission was in the mission was we are covering objective. We are putting all country going to be covered with the data. And the country data, and we are government of 50 more data, 100 data covered all over the country, all the part of the covered by data. If 10 minutes the data is given. And also first time wind forecast or the microwave station are being introduced. So this promising mission goes on. We are going to get the board there. And also, whatever the satellite data, whatever radar data is coming, we are going to integrate rapid refresh. So with that I think we will cover.
Thank you, sir. I hope, yeah, okay, fine. One.
Sorry, just to understand. Before the occurrence of this Wayanad incident and Uttarakhand incident, could you able to look at forecast?
Actually, Wayanad thing also, we are able to see weather models, extreme weather forecast, and we are not getting we are getting the peak at the same time, but not the all movements. Highest training but we are getting the peak at that time. So this information we get the things. Not in the medium, actually to our sector, but 10 days. 3 days before, we got the 3 days before we got the that is the problem. See, actually, for example, urban floods. Michelle, I4, Michelle, I4. Can I buy a place? And urban floods. The flash floods still a challenge, but we are not getting that full signal, but some of the numbers acceptable. It is going up to yes. No. Actually,
there is some sort of recurrence also taking place there. You know the zones where this probability is there. So there you can do some sort of localized modeling.
see, flash floods now not only because of only rainfall, actually occurring because of other changes also. So we have to use rain information to that other change information to that. So this is not a multi-project program. It's a combined program. So people are working on that. So,
Even actual cloud bursts.
cloud burst is difficult.
I'm really sorry. Actually, after this we have lunch section, so you can interact with Dr. Prasad in the lunch section. Okay. Actually, I know this is a very interesting topic on which Dr. Prasad was dealing. Now, I'm very thankful to sir. Just to honor me, I request Dr. Naidu sir, HOD, to say Dr. Prasad. Kindly join your hands. Thank you, sir. I think we have us, before lunch, we have 2 short, just an interaction. After that, we can go for lunch. I request madam to just. No, no, thank you.
your PPT in the system so that we can start the session at the earliest after the lunch. Fine? I think I am clear. Thank you. You can join for the lunch, and any doubts you had during the talk, you can continue in the lunch, during the lunch. Thank you.
That is down will be better. When you control want to keep down. This is the volume. This is the volume. To what it is placed? Keep it minimum.
Sir, who is the responsible person for the sound? You just ask. Otherwise,
This is new system. Previously, some students were taken.
you just ask them to come because if you are new, you cannot manage this live program. Can you check with the sound?
Check. Check.
Stage. Check. Hello, check. Hello, check.
So the more concentrated dose. Yes, in any borehole, but outside this, some people concentration concentration. This blue color is the 90% you can get.
Hello, check.
Are very concentrated. So this, if you have data before, so the more concentrated, most of the previous very expensive, you want to have it. But outside this, some people can be
Hello, check.
It is the mind. You have data before. So the more most of the time, very expensive. You want to have it. But outside this, some people can be
Hello, artificial intelligence takes everything. I can see the decision take its own decision. That is artificial
In the
and also seeding from aerial seeding using aircrafts. This is the process. So suppose ground-based seeding means that seeding material using some flares is burned, and aerial seeding means just like I have shown, some flares are burned using aircrafts, or this hygroscopic material means it is sprinkled on the cloud tops. Just a comparison of the formation of a raindrop and its relative sizes. So coming to the practical aspect, IIT has been done very extensive exercise on this cloud seeding right from 1973. So many experiments they have, and this is the percentage of enhancement in rainfall. And recently, like 2018-19, during 18 and 19, 2 years they have done one experiment that is over Solapur district of Maharashtra. There also they could 95% confidence they could say around 46 plus or minus 30% of enhancement in the rainfall. And on average over 100 square kilometers distance, nearly 18% enhancement in the rainfall. These are the some. This is the procedure or experiments they have done by IITM. Coming to Visakhapatnam experiment, it was done during 2002. Aerial cloud seeding was performed using helicopters, and here this is the area of cloud seeding, and this is the result. It was done during 12th and 14th, and the rainfall quantities, you can see the peak enhancement of the rainfall. This is the average district rainfall. These are the results from the Visakhapatnam cloud seeding. Coming to cost factor also, at that time it was only coming around 1 paise per 1 liter. Later in Nandyal also this experiment was done using radar and aerial seeding. These are the results for that experiment. Finally, another during 2005 also ground-based experiment was conducted. Ground-based flares and sulfur-added pots. This reading was performed, and this is the result. You can see the rainfall amount. Nearly 8.4 millimeters, 10 millimeters like that. And this, during the 13th and 17th September, again, different catchment areas of the Visakhapatnam district, again, ground-based seeding was performed. And here also you can see the rainfall amounts over the seeded area. So during this experiment, you can see that 66% enhancement during the non-cyclone period. These are the some of the statistics about the catchment water enhancement in the Eleru reservoir. This is the conclusion, sir. So this is an alternative method, one of the technique to enhance the water resource. Thank you so much. Any questions, please, you can ask him personally. That's better. Okay, thank you. The second one is, yes, Bangar Babu. Yes, Bangar Babu. Dr. Y.S. Naidu Garu. No. Ibrahim Sheikh, P.V. Nagamani Garu, G. Srinivas Garu. Okay.
M. Mohan Babu garu. M. Mohan Babu garu. No. Ramarao Kota. Yes, sir. And one more announcement, call out once again from 15th. Sulochana Rani and S.K. Wagon garu. Please go to that room. And Mohammed Sarif Khan, please go to that room. No problem. And Sabita D, please go to that room. Sabita and others. And P. Anand Kelpudran and others, please go to that room. Dr. A. Yugandhara and others, please go to that room. The rest of all the people, please go to that room. Thank you. Please.
Good evening to all. Thank you very much for the given opportunity. As a student here, first time I'm giving my lecture. Like my topic is geophysical integrated geophysics approach to explore gold medal exploration. This is at Cynical Pedigree region, West African region. We did as an exploration there, like real-time gold exploration using integrated magnetic and IP resistive methods. So my objective is to get primary gold. Exactly, my objective is there is a different 16 types of gold geological situations are there, but my gold situation is that is a primary gold, that is a structurally controlled gold deposition formation. But the structural controlled gold formations, how we can approach those structurally controlled formation zones? So we approach like semi-detailed investigation and detailed investigations. From semi-detailed investigations, we have some way paths like how we can find the gold there actually. Using like the geological structures, there is a fault, strike, shear zone formations, and there is a lithological contact zones, and another one hydrothermal activity zones. These are the key parameters. We can find it using the geophysical methods. So in that parameter, in that zones, we have to find out using these semi-detailed investigations. Particularly in the ground magnetic high resolution ground magnetic survey we are carried, and initially remote sensing data and the radiometric data we are initially analyzed that we some zone is there, so we identified like that. Then after we go for a detailed investigation and IP restricted survey in that area, there is the charge zones are there, particularly that target zones we do. This is the Senegal region. It's a Kedugu, one of the survey region. That is my target zone is almost 56 square kilometers area in the Senegal Mali border. This is one of the richest gold mineral, like world most richest gold mineral zone in the world. Also, there is a lot of depositions are here, and in that area, I am going to. We read these are the parameters. We go follow this and like IP resistivity methods and gravity night methods. Sorry, and this is the zone actually. There is a well established I am told is there from the my survey area from there. I am told one of the richest gold mineral exploration companies, and Sabutra, one of the gold mineral, all the remaining, all the mineral exploration companies are established what is going on there, the real time. That is actually that the geological situations are there. That geological situations are there is a Senegal Mali shear zone is there, and one more is there, Masari tectonic shear zones are there. These are the my study area around here actually. This Senegal Mali shear zones and Masari tectonic shear zones are there. These two zones are major. These are all the world class gold exploration site companies are there. From there, from 2021 onwards, we did magnetic survey, ground magnetic survey, high resolution using proton pressure magnetometer, like continuous recording high sensitivity. Magnetometer is there. We did all the areas. There is actually real-time artisanal mining activities also going on there. There are a lot of people are doing activity also. From that area, we are marked like this. All these parameters we are carried out. From there, we finalize the overall 50 square kilometer area. We are synchronized like a particular zone. We are classified like 6 or 7 zones. In that zone, one of the zone, we are interested to go for detailed investigation. For detailed investigations, we from magnetic data, detailed investigation purpose of what criteria we followed here is there is a structure. There is a structure. So these are the major fault zones, the black ones, and there is a secondary faults also there. These intersection zones, wherever the cross section zones, these are the artisanal mining. That means local people, they are digging there, they are taking that material and they are doing manually, all the activities they are illegally doing all those things. So in that area, we did all these. This is the zone exactly what we are going. So we are classified like this is the major fault zones are going are there. Then these are the minor semi fault zones also there. These zones most probably our target area. For that we detailed investigation is there. This is one of the IRIS latest equipment. It's like half-wave recording equipment. We did this with this high resolution DGPS surveys also from Atlas European satellite-based services. They are providing almost the vertical is 7 centimeters and the horizontal is 4 centimeter accuracy of the GPS they are providing. And this is the IRIS transmitter. We are almost injecting current to inside for 6 ampere current, and we receiving the signals. And this is the latest equipment. We can 1.2 kilometers straight we can record within one day. Multi-channel we are operating here. We can switch it automatically will record everything. Like for this is the principle we followed here is like these are the parameters: survey plan, acquisition and processing, and 2D inversion, and all this. And we suggested some recommendations to go for exploration. These are the activities we made here. Like this is the line clearing, and initial 3 days before we made holes and we could play and proper results and proper activity purpose. We every 3 days before we made a holes, and we one side we laid a cable and another side we injected current. We used pole table configuration, and we are recording and cabling and injecting current, all these things. And these are the results we got it from there. So we are based on after inversion, we got it. This the top one is resistivity, the bottom one is the IP results. The resistivity we classified as a 4 sections, like high resistivity zones 1000 meters above, and the moderate. So we geological contact of view high resistance maybe quartz veins like alteration zones. Sorry, not alteration, but igneous formation zones. And the high to low is like some moderate, and the low is maybe where are the clay material or alteration zones are there. That zone we consider the low formation zones. And the also we are classified as 3 stages. One is high chargeability, moderate chargeability, and low chargeability. These are the exactly, this is the high chargeability zone, this is a moderate, and this is the low chargeability zone. There is in the overall line, it's almost 1 kilometer line. In the overall line, this is the artisanal mining activities going in between there, and there is also artisanal mining going on there. Then here also, from artisan mining, where is the exactly local people are making their exploration activities from shallow areas. In that area only we made this all the things. So based on that, we followed 3 major parameters. The top one is magnetic anomaly, and this is the resistivity, and this is the IP. From the resistivity, we are like approximately, this is like a mushroom-like structure. This structure is approximately high. From all these things, we are from resistivity, we classified as this is the holding situation. So that's why this is the undulations are there, and this the IP is that within the folding zones there is a IP. All the high zones are below the 40 meters below. Because we are a physical evidence, the artisan people, they are going deeper, almost 40 meters deeper. They are drilling the material. By manually, they are taking and coming out, and they are doing like all these activities. So for this, we did like these correlations. From another one more line also there, we did same the interpretation. There is a fault zone. Exactly, these fault zones are most probably. And the most thing is wherever the magnetic signal is going up, increasing. That places mostly the resistive, moderate resistivity is there here, and there is a chargeability zones are there. There is a geological situations we know everyone knows. Wherever the high chargeability is there, that is like sulfide materials, and there is a high resistivity is there is a quartz or a high. So while these combinations is the one area of gold, then particularly the structurally defined gold formation zones. So another one more scenario is there, the moderate resistivity and high chargeability zones. These two classified we are going on this. For overall that area, we covered almost entire from 7 to 8 hectares area. We did all the IP service and as well as see there is a correlation. This is there is a sorry there is a this is the low resistivity line and this is the high resistivity line. I combined all the data whatever that all the lines we combined it and the comprehensive I see this is the high chargeability high resistivity, this is the low resistivity, this is the high resistivity, this is the low resistivity. There is a alternation that's like first is high and low, high and low. The humping situations are there in that situation. These high and low resistivity zones overlap with the chargeability zones. The chargeability, so wherever the high chargeability to moderate chargeability, high to moderate resistivity zones are there, there is a high chargeability situations are there. So that is the my primary target to be given there. This is the 3D view of the entire area. Almost top region, we didn't find any high resistivity. From 100 meters onwards towards 200 meters, we got a high resistivity zones. As well as from IP also, we are clearly discriminated from 100 meters above onwards only we got it for high chargeability zones. This is the high chargeability zone. The real time they are doing there 100 meters depth onwards we are getting. This is the 3D visualization. We did 3D also. Like this is the my objective is what we observed here that in that situation what we have moderate resistivity, high chargeability zones are mostly possible of gold bearing zones, and we given based on 3-4 different ways like high chargeability, high resistivity, some drilling points we given, and moderate and high chargeability, and some situations where the shear zones are there. That shear zones we given some extra scouting purpose that recommended some gold, some drill holes. So based on we did this work, and we have a limitations. All these geology, and we have elevation and moisture content, all those things, and geologically also we have a big challenge. If there is a clay material, the clay material and sulfide materials both are give you same factor. So that is also for that purpose we have to go for scout drilling. This is a team we almost 6 months we did IP survey there, and all my colleagues, my seniors, my juniors. We are from Capstone, so we are basically providing all the service, not only gold, all the exploration activities we are taking there. Like all the services, we are globally working here on the African countries, and these South America, India, all the countries. These are the services we are providing there here for as a consultancy services. Thank you, sir. So mostly we are getting there is a shear zone, like the dolerite, almost limonite, like like below is soil. That mostly that soil has a limonite behavior soil. It's almost within the hard work that there is a like a loose material, like a clay like material. We are getting there. That is why we are low high charge to get it. Suppose these local people are artisanal mining people, they're almost 40 meters they are going inside. So in the rainy situations, what happens? There is like a recharge. So the overall water area will be like high charge is become water effective. And one more thing is there, the top line almost like cap rock like no sir, not same. Laterite. So laterite formation is almost 10 meter thickness laterite formation is there. That purpose only we did the drilling also for pore spots. Wherever they are keeping pore spots, high charge for recording. We put 3 days before onwards we made a water and filling all the things to high charge that moves. I'm not sure, sir. The 3 chemical type definition only. This is actually Birmingham greenstone methodology. This is entirely from West Africa to West Africa. Yes, West Africa region that is like Mauritania. From Mauritania, Argentina, like Guinea Conakry, and like this Mali border, this country, continuously this is the zone is going on. Yes, this is what.
Thank you, Ram. Coming to PR Nani, Venkatagiri and Ramadevi. Electrical resistivity techniques. To identify groundwater prospect in a granitic terrain, a case study from Rangareddy district, Telangana. Please come. So you take Please maintain silence. Thank you.
Respected chair and co-chair of this panel, and pronouns to very senior members of this department who have who are the pillars of this department and who have made a good foundation for the future generations, and really pronouns from the Central Groundwater Board to all the alumni of this department, and my dear students who are the future geoscientists. So last 2.5 days, you were hearing a number of presentations in that it started from how we can place the satellite data. That is from the space we started that. And when we have seen that a lot of presentations on the oil exploration and gas. And then we have came to the mineral exploration and we're coming to the Mausam, that is climate also, weather predictions also we have seen. So all these, whatever it is oil and gas, I think it's improve the economy of the country. It's basically, so ultimately when the economy of the country has been increased, our state of living and the standard of living of the human resources will improve. But for the sustenance of this human resource in this planet, a main resource is required, so that is the groundwater. So I am from the Central Groundwater Board, so whatever for the 2.5 days we are hearing, even though the economy of the country has been improved a lot, for the sustenance of for the utilization of the proper resources, we need a sustainable groundwater resource for the mankind. So I will not be taking much time because we have reduced the slides to a minimum. So we don't want to make it trouble for the organizers also. Thank you for the organization for providing an opportunity. So this is a case study we have taken up as part of the AAP, and this is a broad outline of my presentations. And why we have selected this, as we know that the entire world, entire land area, we have, because of the advent of the technologies, we have the borders. And there was unscrupulous exploitation of the groundwater throughout the area, which resulted in a decline in groundwater level. And moreover, with the advent of urbanization and industrialization, with the advent of the technologies, apart from the decline, we have the groundwater quality problems also that is really deteriorating the quality of groundwater in the aquifers, that is contamination is there. And we have selected an area near to the capital city of Telangana, that is where the Hyderabad airport is situated, that is Shamshabad, Maheshwar and Kottur of the Regulatory District. So we found that the entire area is underlined by the gneiss, that is granite gneiss. So it has an inherent quality that it can't sustain water for a longer time. That is sustainability issues there. Then we have identified that there are some pockets we have deeper water level and shallow water quality issues are there. So earlier we were advocating for the development, how we can develop the groundwater resource. And for the last 1 decade, all the ground people who are in the farm and water sector has given a paradigm shift from the development to management. How we can manage this sustainable management of this resource. So then that time, Central Groundwater Board has started a flagship program called the National Aquifer Mapping Program, that's acronym of NACPM, that we have launched during 2012. And we are proudly to say that we are the first country to map the entire aquifers of our country in 1:50,000 scale for a mappable area of 24 lakh square kilometers. But when we compare to the NACPM one, what we find out that we have devised a number of management measures, but it was not in an implementable scale. So we launched a NACPM 2, where the scale was being reduced to 1:10,000. So it will give a more pinpointing implementable management plans for the sustainable development of this resource. This is a steady area, hardly 550 square kilometer part only I have taken it. So it consists mainly of 3 mandals, and the Hyderabad airport and a number of industrial clusters are situated in these 3 mandals of this regulatory district. And these were the aims. The first one is there is a decline in water level and we have a shortage of water supply. So we have to find out the groundwater potential zones in this area. And second one, because there is an increase in the pollution possibility because of the urbanization as well as the industrial clusters are coming up. We have to see that what is the aquifer vulnerability of that particular aquifers in that area. These were the 2 aims we have taken up in the study. A few meters the groundwater prospects in an area, because earlier in the plenary section also Venkateshwar sir has explained very nicely about the aquifers in the eastern ghats where the pondline is there. The situation is different. Here it is a granite we have, and we have selected since we have a number of components are there. So one component was the geophysical part. We have selected the very simple and most economical method, that is a vertical electrical survey using the Schlumberger app. So we have done, and in this 550 square kilometer, we have taken up 73 vertical electrical surveys. And here we were able to identify, because we have done the field global match method, and using the softwares, we were able to identify the different layers. Because topsoil, weathered layer is there, then we have the fractured aquifers, massive granites, and within the massive granites also we got the fractures. So in this one, from the primary data, that is from the best survey, we could get the layer resistivity. From the Schlumberger arrangements, we got the resistivity, and we were able to identify the layer thickness also of the different formations. And from the primary geoelectric layers, we try to derive the secondary geoelectric parameters using the TEZ parameters. A number of gas rock parameters has been mentioned here. Because of the constraints of the time, we have done a detailed analysis of all the parameters. But here in this presentation, I'm mentioning only about the longitudinal conductance because of the time constraints. So, beginning, we have identified 3 to 5 geoelectric layers, and the predominant curves were H, HA, and H types, A types. So, when the H type curves comes, it indicates that there is a presence of groundwater. There are possibility or probability of groundwater is in that particular curve. So, majority of the area, it is more than 50% of the curves has been categorized in this one, and this is the map showing the resistivity of this one. And we can see that eastern part, this eastern part having the resistivity. This is the resistivity of the massive formation, and eastern part you can see that the resistivity is low. So it means that the eastern part of the area we have the massive granite that are fractured. That's the one thing we have found out. These are some of the curves we got it from the areas for different types of curves. And now we have the next thing is we have to identify the groundwater potential zones in this area. As we know that there is the urbanization, industrial clusters are there, and it's very difficult to get a space for all the surveys and as well as for the groundwater exploration. So from the resistivity values, we have derived the overburden thickness. And the overburden thickness, it shows that the eastern part of this one, this part is having a thickness of more than 20. Okay, and the remaining, that's the high radiation, spatial radiation in the weather thickness. Even though the bedrock is granite throughout the area, it shows a high radiation in the weather thickness, and eastern part shows maximum thickness. And here, this is the reflection coefficient. So, reflection coefficient, it shows the how much the basement rock is fractured. So, from the reflection coefficient also, we could see that the eastern part, here this much is the area having the high thickness, but it has been restricted to a small patch here where the reflection coefficient is less than 0.8. So when the reflection coefficient is less than 0.8, it means that there is a very probable fractures may be there. That is answer. So based on the literature survey, we have seen that Nigeria and Egypt have a lot of groundwater exploration activities where they have utilized the geophysical method as a prior for the groundwater exploration site selection. So we have followed the methodology they have followed, and we have combined the maps by giving the weightage to find out the groundwater prospects. And so we combine the overburden thickness and the reflection coefficient to get the groundwater potential zones. Meanwhile, we feel that during the survey, we noticed that some of the areas there is a scarcity of water a lot. So since we have a monitoring wells, historical water level data for a longer time, we prepared the depth to water level map to see that what is the scenario water condition, and we have prepared for the post-monsoon and the pre-monsoon. And this is the area during the pre-monsoon we have seen that the water level is more than 40 meters. And even during the post-monsoon also, we are getting some patches where the water level goes 40 meters. So it means that the overburden thickness is 20 meters and the water level is 40. The first aquifer has been dewatered or desaturated due to the overexploitation. That is the one indication we indirectly derived from all these maps. And from this overburden thickness and reflection coefficient, we have demarcated the area and finally divided the zones, the entire area into 4 zones, and the 40%, around 48% of the area, it shows the high yielding to medium yield zones. They are very potential for this one. This was a major one. And later, to validate the whatever groundwater potential zonation, what we have done, we have taken a groundwater exploration activities also. So it was it has proved that 86% of the we have suggested by the best studies proven to be successful. We got up to 4 LPS also. So that was really it was a boosting for us because it shows that whatever model or whatever theory we have followed, it was successful. And this is the some of the sections we 2D and 3D pictures we have prepared using the BESS and the litholog data. And we have tried to validate the depth to bedrock what is interpreted from the best geophysical data as well as from the expression set also. Both are matching. So both are congruent. And finally, then now the next part is urbanization daily in the water. Next is the industrial sector. That industrial sector, the problem is when the industries come dispose of the waste. Where to dispose the waste? So we feel that future it may contaminate aquifers. We have taken the aquifer vulnerability study using the geophysical surveys, and here we use the parameter longitudinal conductance. So this has shown that these are when the longitudinal conductance is high, it shows that there are less chances for the infiltration of the contaminants enter the aquifer. So we were able to identify the area also where there are less chances for the contamination. So this can be recommended for the district administration that these are the suitable sites, or whenever they are recommending any industrial clusters or permission granted for them, we should be careful about the disposal of the industrial waste. These are the sites where it may contaminate the disposing. So these are the precautions we could be able to give unto that. And finally, we are able to this one, three categories, whether where it is a good, moderate, and weak and poor. And we have seen that it's generally good to moderate country. The majority of the study area is not, none of the area is categorized with excellent. So this is my conclusion. So because we were able to identify the areas suitable for artificial recharge, because those areas has been desaturated or dewatered, that area has to be given priority by the district administration to take up the artificial recharge studies. And next, we were able to identify the groundwater potential zones as well as the groundwater vulnerability. So this study proves that it will be highly useful for the policymakers as well as the urban planners to make a harmonious coexistence of the development and groundwater sustainability. This is the conclusion of the study. Thank you.
Thank you so much. Thank you, madam. Completed the time. Next is K. Rambabu, Venkatagiri, and others. No. S. Bangar Babaru? No. K. Srija? I think she was next is Reshma S. Reshma, Swati, and others. Monica Vijay Ketan Mohanta, MS Gautam, Sriman Narayan Garu. Then it's over, I think so. Last one. D. Madhav. Narani. Absent, okay. Ramesh Chandrapani. That's all. Okay then. So all are okay. Any absences are here. So that's all we concluded our session. So in this particular session here, yes, okay, sir. Thank you. So successfully completed session. All are cooperated. Thank you very much, sir. Thank you very much. Thank you all. Our Guru is here, Professor D. Bhaskaraga. Can you speak few words, sir? Now, within few minutes, we'll start our, yes, sir.
I would like to raise few points to my groundwater expert.
Want to raise some points? Please.
The major challenge we are talking about is that groundwater markets.
Yeah, you please take it.
As we are going ahead, at present the water goes out. I also work with groundwater. The major challenge what I'm feeling is that whatever the water we are pumping, operators different UV operation and water. My bore water is going into 30% or 20%. Remaining water is being pumped again to the ground. What are the steps and what are the regulatory steps? Next aspect, what we are talking about is water. Because is something and has to be more than whatever. My another aspect is groundwater exploration. Okay. So last few months back, I went to state groundwater board. I'm seeing the water tables 10 meters and 20 meters. What the challenge is, I don't know. But in the entire city in Hyderabad, the water table is more than in the summer, maybe. So the resistance is not going to help me in getting that. So we are using to some extent in some areas magnetic filtering. Magnetic filtering will be giving this factor. Identifying a factor and or any other possibility.
Thank you. What I feel is that I think class is explain the fractures, and what we find out in our study, we try to analyze the fractures also, and we have seen that all the fractures are not needed. Okay, so we could identify, and we have seen that we have the feeling that whenever there is an increase, it may improve the groundwater conditions. It may reach up, but in our study area, we could find out the increase that is acting as a barrier for the groundwater process. You see the resistance of the method the resistance for the district administration, at least we should give some signal that whatever distance.
Because I'm facing the challenge. My society is approaching me. So I identified the fracture. But then before drilling, I am constrained myself, saying is that I'm drilling into a fracture. What is the guarantee for me that there is a water? Okay, I'm getting a disadvantage. How I am going to keep money because next reservoir or next fracture. It is not a direct circuit. It's
like a oil and gas development in the groundwaters are also can happen.
Today for me, my challenge is even though I have the technology, I have to sit there and I'm not taking classes. Right. Okay. Today the challenge is 1,000 feet of water table. Even central government, I don't know how much I think you started in whatever. So in almost all the cities, I'm having a flat here in Madhurwada. I'm having a flat in Madhurwada. So there they said the water limit is waterfall 450. I'll be going to manage the other
I want to clarify for your doubts. First of all, the groundwater availability
drastically reduces in exponential form. That means the water that is available within 100 meters, most of it goes out. Okay? Whatever that you got at 1,000 feet or 2,000 feet, even if the borewell is succeeded, it will not work for few months. Okay, that's number one. But in case you want to explore that, anyway, you have a deep residue surroundings are there, and that airborne. Airborne surveys are there. That is how they. But in a urban environment, it's a big challenge. Nobody can investigate 1,000 feet, 2,000 feet water there. That is a 100% fact. And that too, that are not sustainable. Please leave it that. If you have a money, you can drill up to 2,000 feet. Nobody will accept you, but it is not sustainable. Okay.
Sir, I think all the societies in Hyderabad are running at a rate. They are running.
Running, I tell you, running, see, no, I will tell you the answer. Since the column is around 1,000 to 1,500 feet, they operate for about half an hour. They pump the stored water. I tell you, they pump the stored water. They cannot pump continuously for hours together. This is the
Of the 8 boats of my plants, 6 boats run for 22 hours and they are giving only 2 hours rest. After my repeated requests also they are not cutting down. So all the 22 hours they are running. But the yield is falling. Yield is falling. Yield is falling. Everywhere that 500 to some boats are there at 500 feet. It is a big challenge today. See, because my question to my experts where they are put up a recipe over there. Thank you.
so balance.
This poster just to remain. By default, as
you.